So I set out to prove that u equals negative g times m1 m2 over r. So it's found in 6.8. So you can ignore all this stuff. This was the warm-up. What I'm really interested in is, let's see if this works. What I'm really interested in is what the chapter got to later on. So first of all, I started by defining my system as two stars. So these guys, like the diagram said in the book. This is star 1, this is star 2. And next, and then I identified the forces. So there's no external forces because my system is the two stars. And the only significant internal force is is the gravitational force between these. So the gravitational force of 1 on 2, the gravitational force of 2 on 1. Next up, I use the work definition to write the equation for the internal force. So change in internal energy is equal to the negative of the internal work. Next, what happens is I simply end up rearranging this equation until I can integrate it. So first of all, I identify that the force of 1 on 2 is equal to the negative of the force of 2 on 1 by the principle of reciprocity. So that turns this equation into simply change in work internal equals the negative of the force of 2 on 1 times change in R2 minus change in R1. Because work is happening, because the star 1's traveling this way as FG is acting on it, and star 2's traveling this way as star 1's acting on it. Okay, next up, this is where I simply rearrange, like I said before, I rearrange R in order to get an integratable form. So essentially what happens is that change in R2 minus change in R1, oh, there should be a little vector sign here, becomes simply delta R. And this happens because we break change in R2 and change in R1 down to their components. So R2F minus R2I and R1F minus R1I. And next we simply rearrange. So we get R2F minus R1F minus R2I minus R1I. And then simplified, that's RF minus RI equals delta R. One thing I am confused about is I understand why R2F minus R1F is equal to RF, because R2F minus R1F equals RF. But I'm not quite sure why R2I minus R1I is equal to RI. And that's just one area which I'm kind of confused about, and I know it's important because I think it involves how we're supposed to think of this as maybe one force acting on or acting over a single distance, but I'm not quite sure I understand how that works exactly. So that's a confusion I have. Anyway, now we simply rewrite delta energy. So change in U equals negative work internal equals the opposite of F of the gravitational force of 2 on 1 times delta R. And now we simply integrate in a new form. So, and we make the change in U and the change in R infinitely small. So change in U becomes du and change in R becomes dr. Thus what we have is du equals the opposite of the gravitational force of 2 on 1 times dr. So we integrate both sides. This is going to give us simply 1, because there should be a 1 here. This is going to simply give us u, and then we can take out all the constants from this side of the equation, put them all over here. That leaves us with negative 1 over r squared, which, using simple integration methods, is positive positive r to the negative 1. So that leaves us with, oh, it cut off, but u equals g m1 m2 over r. That's it. Hey!